In this section, I'm going to be covering what's known as the tech stack. The technology stack starts with the language you're using. And what I'm showing here is the current popularity of various languages over the past 15 years. As of 2018, something big happened. Python surpassed Java as the most popular language, noting that this popularity index comes from essentially who's Googling what. The language, though, is important because this is going to determine the types of work you'll be doing. It's also important to note that you really want to make sure that the languages that you're working in are a part of this list. There are other less popular languages, but the problem with them is going to be finding work. The higher the popularity of the language you're working in, the easier it's going to be able to find work. Taking a look at these popular languages, it's important to understand what those languages are typically used for. What I've done here is separated the world of languages into front-end, back-end, scripting, and operating system. We'll start with something that's probably the most common, scripting. Scripting is just a means of doing some automation without having to compile or transpile or turn stuff into bytecode. The most common scripting languages you're probably familiar with are going to be things like Bash and PowerShell for Windows. Then we have our typical software development world of front-end and back-end. With front-end, this is going to build graphical user interfaces. This will include mobile applications, cross-platform mobile application development, web-based front-end development, and even desktop applications. From a back-end perspective, this is going to be establishing web services. It's also important to note that we have operating systems themselves. They are, in fact, software. However, most of the work you're going to find is going to be in the front-end and back-end space in terms of software development. It's important to note that a lot of these languages are cross-functional, and also a lot of this is open to interpretation and opinion. For example, we'll take a look at Java, the second most popular language. You're going to find Java almost exclusively in back-end server-side development. However, you can technically do front-end development in Java because we have languages like Swing, and prior to that the Abstract Windowing Toolkit, OUT, but those are desktop applications related. Also consider from a web-based perspective, you have Java Server Pages, which are sort of Java. They're processed like Java in a Java virtual machine, but they become less popular for doing front-end based development. However, from an Android development standpoint, you're going to be using Java. Also, still sticking with Java, just looking at the Java virtual machine, the thing that's running the Java environment, there's other languages that work inside that same environment that I've highlighted in orange here. Kotlin, Groovy, and Scala are all languages that are a part of the Java family. They're going to run inside of the Java runtime environment. Taking a look at aspects like Kotlin and Groovy, though, these can be used primarily from a scripting perspective where you're going to find them as core capabilities within Gradle. Because these technologies, though, work inside the Java virtual machine, that means you can also use them to do pure backend development. You can write web services in Groovy. Another good categorization of programming languages are from the Microsoft and .NET space. This is because there are several languages that all work within the .NET environment. The more common ones are Visual Basic and C#. You will typically find Visual Basic and C# as being used for backend or RESTful service development. However, inside the .NET stack, it's also possible to use them from a server-side application perspective used to render the HTML-based front ends. However, this type of server-side scripting is less common in favor of technologies like JavaScript. There's also VBA, which is the Visual Basic Application Framework, more geared towards desktop application development. In the middle of a lot of this, we have things like JavaScript and TypeScript. This is because while primarily used to do web-based front-end development, they can also be used to do back-end development. Through technologies like Node.js, you can run them as server-side applications. They also worked for general scripting, though, because they are, after all, scripting. And with inside technologies like Gulp and NPM, you can actually run JavaScript as command line level operations. We then have some more specialized outliers, for example R, which is used for a lot of data science and analytics. Where this exactly fits in is open to interpretation. Also, much like MATLAB, there can be front-end and back-end type implications. MATLAB is used more from an engineering and mathematics perspective. It's more of a tool suite for being able to work on formulas and algorithms. Also within the web space, it's important to understand that PHP is still a very common and popular language, being number 5 on the list. This is going to be used from a web development standpoint as a server-side scripting language, meaning that it's used to execute code to render the HTML that is then processed by the browser. From a modern software development perspective, it's more common now to find PHP on the back end through technologies like Laravel, and then relying on JavaScript to do front-end based development. We can then start talking about some of the more specialized languages. For example, if you're wanting to do operating system based development, whether Windows or Linux, you're going to start seeing C and C++ for their efficiency, their memory management, and for higher level operations, especially when talking about things like Mac, you can actually use Objective-C, which is another layer on top of C++. C and C++, though, are very commonly used inside desktop applications dealing with graphics. And so you're going to find a lot of the underlying engines for 3D games are going to be done in C and C++. When looking at the mobile space, as mentioned before, while you can have Java for doing Android, you're now going to see Swift as the language used for iOS. Objective-C, though, was formerly the language used for iOS-based development. This is all important because you're going to be the best at one language, and that one language that you're best at is going to determine where you're going to work inside of the front-end and back-end or otherwise scripting space. It's also recommended that you don't stick to one language. You're going to need to learn another language at some point in order to be able to work more fluently across the full stack. Beyond language, there's other aspects of the tech stack. And to start with, there's the cloud. It's becoming less and less common for application systems to run on physically located hardware. Most systems now, if not all on the cloud, are going to be either going there or already running some part of themselves on the cloud. This is why it's important to understand what the options are in this space and in terms of their popularity. At the moment, as of 2022, AWS is still by far the most popular and the leader in terms of cloud-based infrastructure, with Azure, Microsoft following closely, with about 21% of the market share. You will also find something known as the Magic Quadrant. This is something put out by a company called Gartner, and there's many of these, but it's a way of dividing up a space into not only how popular, but more importantly, who are the leaders in some certain group of technology, who's a challenger, and also which ones are being visionaries versus the ones that are able to execute. And so if you look at this Magic Quadrant, you'll see that you have your 3 main players as the leaders being Microsoft, AWS, and Google. But then you have some visionary work being done by places like Oracle. And then you're otherwise going to have some of these niche players that aren't quite at the same level, like the IBM-based cloud development that are trying to make a name for themselves in this space. This is important because generally speaking, a company is only going to be on one cloud. It's going to be very rare for a company to be using multiple clouds. And so the cloud that you're most familiar with is going to steer the types of jobs you're going to be able to apply for. Running software is complicated. So it's especially important that as a software system is running, you have some way to know that it's running and that it's running well. This gets into an area known as performance monitoring and observability. This has become a key component of any technology stack because there's going to be a set of involved applications and other supporting infrastructure used for doing things like keeping track of application logs, knowing whether something is running, monitoring memory and otherwise performance, and just being able to trace how something's working from end to end. Consider that the days of having a single server that you log into and grab log files off of is pretty much gone. These cloud and web-based applications aren't just going to be one server, they can be dozens, hundreds, and in some cases, thousands. So having to pull logs by going into thousands of computers is completely infeasible, which is why technologies like Sumo Logic and Elasticsearch have become players in just the logging space. But that's not enough. Telling how stuff is running and being able to know whether it's up or not, which is why you then have tools like Dynatrace and New Relic, which are handling application performance monitoring. Whenever you're looking at some type of job specification, you're going to see some of these aspects probably in that specification. They will directly call out Dynatrace or New Relic or Splunk or Elastic. And so you want to also make sure that you're up to speed in at least one or two of these areas because you're likely to encounter them. Almost every application is going to have to store its data somewhere, so it's important to understand the types of database management systems that are available to you. At a high level, I'm only talking about what's going to be available via the cloud. This is going to be a subset of all of the available database technologies without getting too specifics, but it's important to note here that your experience with cloud infrastructure is also going to help steer and direct you within terms of what the different data storage technologies are that are available to you. This becomes even more important if you're working inside the data science area of software, because tools like Databricks, for example, and Teradata are going to be some of the options you're going to have to work with in terms of the space. You should also note that within each one of these technologies, when we say things like Microsoft, it's referring to the options for Microsoft database management. If you're looking at the underlying implementation, it's going to get into details like Microsoft SQL Server, as opposed to things like IBM, where you may be talking a different database technology entirely. Most cloud offerings, though, such as AWS, are going to have multiple options, from NoSQL databases like Mongo to more traditional relational databases like MySQL. A key aspect of the technology stack has become how that technology goes from a developer's box into the production environment. And that gets us into the continuous delivery and release automation section. These are going to be the underlying technologies for which you instruct how to build and construct your software, test it, and ultimately deploy it. While this will largely be based on what your source control and cloud provider is, for example, if you're on Azure, you're probably going to be using Azure DevOps, but if you're also using Git, you can use Git's own pipelines. There's also completely independent options. For example, CloudBees, more commonly known as Jenkins, is a way of independently hosting a continuous integration server. Another key part of the tech stack is going to be your IDE, more commonly known as your integrated developer environment. It is the code editor that you're using to work on a code base. That's because a lot of these tools are more complicated than something you can just open in a regular text editor. You want to be able to check them, run validations against them, compile them, run them locally, and so that gets us into a series of technologies used for doing that. Popularity aside, it's worth noting that each one of these development environments is going to support and be geared around a certain technology stack. For example, Visual Studio is something which is going to be focused on the Microsoft or .NET technology stack, while Visual Studio Code, a lighter weight version of that, is focused along those same things, but also includes support from everything from Java to other types of application development, such as JavaScript. Eclipse is going to be focused almost entirely on Java, where Android Studio is going to obviously be most focused on Android. PyCharm for Python, IntelliJ is primarily for Java, along with NetBeans. Sublime Text is a generic and common one. Xcode is going to be for iOS mobile application development. It's also important to note that the IDE is something which any given company may have multiple of. It's really a matter of team preference. Which one are you most comfortable working in?